Hello everyone, good morning. This is Dr. K. Naik and today we are going to learn PLSM modeling. So let's ask first question to ourselves, what is PLSM? It stands for partial least square structural equation modeling, and it's a very popular second generation multivariate data analysis techniques which is used for testing hypothesis of existing theories and concept, and it is also used to develop new theories and concepts. It focuses more on predictive ability of the model, and it also focuses on the explanatory power of the model. So before doing any analysis using smart PLS software, a researcher needs to ask few questions about the data characteristics, and then only he should use PLSM. So let's try to answer the question when to use PLSM. When the sample size is small, then we can use PLSM method. And at the same time, if sample size is large, then it increases the consistency of PLSM estimations. The data distribution can also be not normally distributed, and PLSM is a non-parametric method. So if data are not normally distributed, we can use PLSM. And scale of measurement should be metric. The data should be available to the researcher in a format of rows and columns. Then we can use PLSM. And it also accepts missing values below 5%. So basically, two most important characteristics of data one needs to observe as a researcher, that there is no requirement of normal distribution and data must be in matrix format. Then you can use PLSM. And why should you use PLSM? As per Arbach and Aleman in 2010, they have given certain guidelines. Why should we use PLSM? So PLS makes fewer demands regarding sample size than other methods. PLS can be applied to complex structural equation models with large number of constructs. PLS does not require normal distribution of data. PLS is able to handle both reflective and formative constructs. PLS is better suited for theory development than for theory testing. PLS is especially used for prediction of the dependent variable from independent variables. So PLS can handle first and second order both together. So these are the few reasons why should we use PLSM. So I would like to divide data analysis using smart PLS into two categories. Number one is assessment of measurement model, which is also known as outer model, and number two, assessment of structure model, which is also known as inner model. So when we talk about analysis of measurement model, we have to check six criteria: three for convergent validity and three for discriminant validity. So to assess the convergent validity of a particular construct, we have individual item reliability, and the threshold value is greater than 0.708. And the composite reliability of a particular construct should be greater than 0.70, and average variance extracted should be greater than 0.50. So these are all threshold values, and whatever value we will generate should be greater than these threshold values, and then we can say that our model fulfills the requirement of convergent validity, and further we can go for the measurement of discriminant validity. So convergent validity is at individual item level and construct level, and discriminant validity is between the two construct. So I will demonstrate using next PPT also and using software also. So when we try to measure the discriminant validity of the constructs, then we are supposed to find out the fulfillment of the requirement of three criteria. Number one is cross-loading. Number two is Fornell-Lacker criteria, in which we do find out the root square of the average variance extracted. And the third one is HTMT ratio. Heterotrait monotrait ratio should be less than 0.85 between the construct, and lower the ratio, better is the discriminant validity. So once we do fulfill all the six criteria of measurement model, then only we can go for the assessment of structure model. So as a researcher, first of all, we have to uh, find out all these 6 criteria using smart PLS softwares, and we have to ascertain that they fulfill all the criteria of convergent and discriminant validity, and then we should move for structure model assessment. Structure model is also known as inner model, and we do measure R square, which is coefficient of determinations, which measures the explanatory power of independent variable on dependent variable. Higher the ratio, better is the explanatory power of the model. And F square is the effect size. So when you have more than two independent variable, which independent variable has significant impact on your dependent variable, so the magnitude of that effect can be measured through F square. And when you are able to divide your data into training data and testing data, then you can find out the predictive relevance, which is known as Q square. So the result which you can acquire on your training data, how valid those results are on your testing data, that can be ascertained through Q square. So in the older version 3.3 of smart PLS, goodness of fit statistics NFI was available. Only one criteria from AMOS we can find out over here, and let us see in where version 4 of smart PLS it is available or not. And finally, the fifth criteria is hypothesis testing, which can be done through bootstrapping method, and we can find out three important statistics, which is one is path coefficient, second one is t statistics, whether this path coefficient and t statistics is significant or not. For that we do ascertain the p value. So these are the 11 criteria we have to ascertain and we have to calculate using smart PLS software to measure the accuracy of the entire smart PLS model, and whether the hypotheses are supported or rejected. We can determine that using all these 11 criteria. So before doing modeling into a smart PLS software, rule number one, you need to understand variables are of two types, observed variable and unobserved variables. So you have to measure individual item reliability should be greater than 0.708. So in case of PU1, 2 and 3, PE1, 2 and 3 and intention 1, 2 and 3, you have to see whether the values are greater than 0.708 or not. And when you talk about composite reliability greater than 0.70 and AVE greater than 0.50, this will be calculated for individual constructs. So perceived useful, you have to calculate number 2 and 3. Ease of use, you have to calculate number 2 and 3, and intention to use, you have to calculate 2 and 3. But when you talk about cross-loading, average variance extracted and HTMT ratio, then you are supposed to calculate these three criteria for the individual construct. The difference between the construct is measured through the discriminant validity criteria, and whether these constructs are similar or different, that we can ascertain using cross-loading, Thornell-Lecker criteria and HTMT ratio. So rule number one is variables are of two types, observed variables and unobserved variables. So whatever available to you in yellow format is your observed variables, and whatever available to you in blue shape are your unobserved variables. So look at rule number two. AMOS works only on reflective scale. PLS SEM works on both, that is formative and reflective both constructs. So the outer model is known as measurement model and the inner model is known as structure model. So inner model is connected through the arrows and they are represented by blue constructs, the blue circles. So the blue circles are your structure model, and for that you will check your hypothesis whether satisfaction is positively related to customer loyalty or not, likability is positively related to customer loyalty or not, company's reputation is positively related to customer loyalty or not. All those hypotheses we can test using bootstrapping method. This is known as inner model and our structure model. So whatever available to you in yellow and construct is your outer model, measurement model. Rule number, so here are two examples of reflective and formative model. So in reflective model, arrows are coming out of construct and connected to the item. And in formative